All right, guys. Today we're going to be looking at the remove duplicates from a sorted array problem on Leetcode. There are actually two different versions of this, and the big difference is in the second version, which is the medium version or the harder version, they ask you to do basically the exact same thing, but they want you to do it with a O of 1 extra memory complexity. So we're going to just solve it with those conditions, and you can use this solution for either the version 1 or the version 2. Either way, you're going to get the right outcome. So having said that, let's talk about the problem, then the logic of how we're going to solve it, and then finally we'll look at the source code and walk through what the source code looks like. So let's look at the wording for the problem before we talk about the logic. That way you understand what we're being asked to do before we talk about how we're going to do it. So, given an integer array sorted in non-decreasing order, remove some of the duplicates in place, meaning we don't want to add additional arrays to do this, so that each unique element appears at most twice. The relative order of the elements should be kept the same, meaning we cannot reorder them. Since it's impossible to change the length of an array in some languages, you must instead have the result placed in the first part of the array. So basically what they're saying is I can't just reorder it and then cut the array because certain languages don't allow that. More formally, there are k elements after removing the duplicates. Then the first k elements of the nums should hold the final results. It doesn't matter what you leave beyond the first k elements. So basically what they're saying is the k elements should be sort of what you're going to return and say the array from this to this, which is k, is what we're supposed to be looking at, and the rest of the array doesn't matter. Now, one of the big things they're saying here is you need to not use extra space. So we can't use a second array. We can't take numbers and just loop them through and put them into an array. We have to do it with the array we have. So having said that, let's jump over. Let's look at the logic. And then after we look at the logic, we'll talk about the source code and why I did it the way I did it. So for this example, we're going to use the test case array of 0, 0, 1, 1, 1, 1, 2, 3, 3. With that, we're going to talk about sort of what we're going to need, and we're going to just go through the logic of how we're going to validate, check, and update the array. After we get through all that, we'll talk about how we actually do this with the source code. So in this test case, we are going to initialize an I. This is going to be the loop. So in this, we're going to initialize I, and we're going to initialize it at 1. We need to loop this program, and we're going to start at I1. So we're going to have a variable and index. We're going to set that to be 1, and we're going to have a count variable, and we're also going to set that at 1. So what we're going to check is nums1 equal to -1 position here? So one thing I'm going to do, and I had this done on my other paperwork, but we're going to go ahead and do it here just to help. So I want to update all of these really quick just to help check things out. Okay, so what we're going to check is we're going to see if nums I and nums I -1 are the same value. In this situation, they are. So what we're going to do is we're going to include the 0 in the array at nums location 1. So we're going to keep this here. Now that we've done that, we need to update our index counter because we're going to move the index over. So we're going to set our index to be 2, and we're going to update the count. We have 2 zeros. That's what our count is going to be used for, is to track the number of these elements. So we're going to move forward in the loop. We're going to loop again. We're going to say, we're going to bring these counts forward, right? So our index is 2 and our count is 2. We're going to say, does nums2 equal nums1? So in this situation, it does not. So we're going to include the 1 in the array at nums location 2. So we're going to leave the 1 here. So what we're going to do is we're going to move our index over, and we're going to set our count to 1. We have one number 1, and we're going to move our index over 1 since we have just set this number. For our iteration of 3, we're going to check nums 3. Now, does nums 3 equal nums 2? It does. So what we're going to do is we're going to include this 1 in our array, and we're going to include it at nums 3. After we do that, we're going to move our index forward, and we're going to set our count to 2 because we currently have 2 number 1s. For the 4th iteration, our index, we moved forward, and we're going to check, does nums 4 equal nums 3? It does. However, we already have 2 of these, or our count equals 2. So because of that, we do not want to include our nums 4's number 1 in the array. We don't want this here anymore. So we're going to leave our index here because now we're going to replace this number at some point in the future. And then we're going to increment our count to 3, saying we have 3 number 1s. On our loop number 5, our incrementation of 5, we're going to do the same thing. We're going to check nums 5 and say, does nums 5 equal nums 4? It does, but our count is already at 3, meaning we don't want this num in our array. So we are not going to set this number to our nums 4 position. We don't want it. So we are not going to include this at nums 4. We're going to leave our index here. We don't want to move it forward because we haven't used this spot. And we're going to set our count to 4. We currently have 4 number 1s. Now, for our iteration 6, we're going to check nums 6. Do we want the number from nums 6? Well, nums 6 and nums 5 are not the same. Because they're not the same, we want this number 2. So what we're going to do is we're going to set this number 2 to our nums 4 position. So we're going to include the 2 at array nums 4, which is our index. Remember, so our nums index is where we're going to set our nums I. After that, we need to move our index over 1 position and say that we have 1 of these. So just to recap, because this is where things start to get a little bit interesting. What we want to do is we want to keep this 2. In order to keep the 2, we need to set our nums index, which is 4. So nums index equals nums 6. That's what we're going to do. After that, we're going to increase our index because now we're going to use the next position to store our next number. We're going to set our count to 1. Essentially, we have 1 number 2. On our iteration 7, we're going to say, does nums 7 equal nums 6? It does not. We want to keep our nums 7. So we're going to set our nums index equal to nums 7 in order to store the 3 at our nums index, which is nums 5 here. After that, since we've stored the number, we need to move our index over 1, and we need to set our count to 1. Effectively, we have 1 number 3. Now we're on the last iteration of our loop. We're going to check nums 8. Do we want to keep the nums 8? Well, nums 8 and nums 7 are the same. However, we have less than 2 of them, so we want to keep it. So we are going to include the 3, but we want to put it in the array back at the array's nums 6 index, right? So nums index is 6. So we're going to move it back to that position. So we're going to include the 3 in the array at nums 6 because nums 6 is the index we stored. After that, we're going to set our index to 7, and we're going to set our count to 2. Essentially, that's what we've had to do. Now we have indexed through the entire array. We have kept a location, which was our index on where we want to store our numbers. we iterate through, and if we do not have more than 2 of that number, we add it to our array. So when this is all said and done, our array will look like this. Nums 0 will be 0, nums 1 will be 0, nums 2 will be 1, nums 3 will be 1, nums 4 is 2, nums 5 and nums 6 are 3. Now we do still have nums 7 and nums 8 hanging out here at 3. But we will return our index, and that's sort of what you have to do to finish this equation out. So I know this was a lot to look at, and it might be easier for you to go back and just re-watch it and look at it and see exactly what the logic was and how we were maintaining our positions. So we're going to look at the source code, and I'm not going to type it out. I've already typed it out. I've already ran it to make sure it works. So it's just faster to talk through the code with you. This is the solution that I chose. Now, I'm sure there probably are cleaner ways to write this, but at the end of the day, it does accomplish the task. We are able to do this with O of n time complexity and O of 1 space complexity, which is going to be one of the better ways you can do it. So in looking at our code, we need to establish an index and a count. And these are things we talked about when we looked at our spreadsheet, right? We need an index so we know sort of where we are going to update our array. And we need a count to know how many of each number we have seen, because we don't want to see more than 2 of them. So what you're going to see first is this if nums length is less than 2, return index. This basically just says, hey, if the array is so short, just return index. It's fine. There's not going to be any duplicates. It's going to work out fine. You're not going to exceed what's being asked. So outside of that, where's the working part of the code? Well, it's in this else statement here. So if this isn't true, then the next thing we're going to do is we're going to create a for loop. That for loop is going to initialize our counter at 1, and then while I is less than the length of the array, we're going to iterate it up 1 time. And that's basically what we saw on the spreadsheet before, right? We saw that we did it 1 through 7 times, 1 through 8 times, depending on what you're doing. So the first question is, does nums I equal I minus 1, which is exactly what we saw in the spreadsheet. The green number, does that number equal the red number? So if those numbers are equal and our count is less than 2, meaning we have, 2 of those numbers or less, what we're going to do is we're going to set the index, or nums index, to be nums I. So that was the blue box that we were moving. So right now we're starting out at position 1, index is at 1, so we're just going to set nums I, or nums index, which is nums 1, equal to nums I, which is 1. Now, after we've done that, we're going to move the index over, because that's going to be the next position that we are going to store numbers at. And we are going to increase our count to say, hey, there was only 1 of them, now there's 2 of them. So as long as those conditions are met, right? So as long as the number we're looking at and the number behind it are the same, and the count is less than 2, we are going to set the nums index to be nums I. We're going to increase our index, and we're going to increase our count. Outside of that, the next thing you're going to be looking for is, does nums I not equal the number behind it? Right? So in this situation, what you're going to do is say down here, this 2 does not equal this 1. So what we want to do in this was we would want to set nums index, which we've been maintaining up to this point, to equal nums I. Once we do that, we're going to set the count to be 1, because we've only got 1 of that number, and we're going to move the index over. Just remember throughout this whole thing that the index is the position where we're storing numbers. Now, when we're done with all of this and we're done with the loop, we're just going to return the index, and that is going to give us the correct solution. Now, there is one thing to note in here, and that is that the count is only being incremented during this, and this is not really keeping a running count the same way the spreadsheet did, but this does do enough to validate this expression, and anything over that isn't really that important. Now, if we run this, you'll see that all cases are accepted, and when I submitted it earlier, it came in at roughly, what is this, 51%. Depending on how many times you submit it, this number can move forward or backwards. It's basically just the test cases you get. See, so now with those test cases, it ran all the way down there. If I rerun it and get better test cases, it could score even higher. See, so we reran it and it beat 98% of the users. So essentially, it's just going to depend on the test cases. But at the end of the day, this solution will get you everything you need. It will get you O of 1 space complexity and O of n time complexity. Now, I know I rambled a little bit, but at the end of the day, this is exactly what you need to do. If you have any questions or have a better way to do it, definitely let me know down in the comments. And as always, have a great day.